Bismillahirrahmanirrahim. So today we'll start the unit 4 and it is about the bonding or ionic bonding. So before starting the topic, we should know some terms and it will be useful while we are doing this topic. Okay, so our topic for today is ionic bonding. Now, first of all, they're saying that the noble gases and electronic configuration. So, what are the noble gases? If you see the period, last group or group 8 of periodic table, so these gases are known as noble gases. Like you have helium, you have neon, you have xenon, you have krypton. All these gases are noble gases. Why they are called noble gases? Because their last shell is complete. If you draw the electronic structure for them, so their last shell is complete. So these are known as noble gases. If you see the periodic table, you can see, for example, now the next page, I'll show you. If you see the periodic table, so this is the last one I'm talking about. These are known as noble gases. Why they are known as noble gases? Because their last shell is complete. What do you mean by that? So I will just explain that one to you. What do you mean by that? For example, helium. The first one is helium. So if you talk about helium, so in helium, how many atomic number? 2 and its mass number 4. So how many protons are there? Because here 2, so it means 2 protons. And how many electrons? 2, because proton and electron always same. And neutron, how much? 4 minus 2, 2. So if you want to draw the, you can say electronic structure, so you will draw like this. Helium and the first shell. In first shell, how many can come maximum? 2. 1, 2. And how much they have? 2. This one. So it means that the first shell is complete. So if their shell is complete, so they are known as noble gases. If you see the neon, if you see neon, for example, here I write neon. Neon is 10 and 20. So how many protons are there? 10. How many electrons are there? 10. How many neutrons are there? 20 minus 10, 10. So if I want to draw the structure for this, so I will draw the first shell. In first shell, how many can come maximum? 2. I put 2. So from 10, I put 2 here. How many left? 8. 8 will come in the second shell. So its second shell is also complete because maximum how much can come? 8. And how many they have? 8. So if you see the all the noble gases, helium, neon, argon, krypton, xenon, radon, all of them, if you will draw their structure, so their last shell will be complete. If first shell is their last shell, so it has 2. If second shell is the last shell, it has 8. So like this, they're all of them, their last shell is complete. So they are known as noble gases. So if last shell is complete of any element, so it will not react. It will not react with other elements. So that it's known as noble gases. It's known as noble gases because they do not react. And why they do not react? Because their last shell is complete. So this is they want to tell what are the noble gases. So go back to the previous page. So here you can see again that the noble gases, the valence electrons are the outermost electron that are lost or shared with other atoms. So they're saying what are the valence electron? Yesterday we discussed that if you draw a structure, for example, I draw helium. So here first shell is the last shell. So here these last shell electron, they are known as valence electron. For example, if I will draw for sodium, Sodium total 11 electron it has. So if I will draw, I will put 2 here. Then the second shell, I will put 8 here. Now how much left? 1. 1 will come in the last shell. So the last shell is known as valence shell. Always last shell is known as valence shell. And the electron which are in the last shell, they are known as valence electron. So here they're talking about valence electron, the outermost electron that are loose. So whenever there will be a chemical reaction will happen, whenever their chemical reaction will happen, so the electron who are in the last shell, they will take part. Either they will lose or they will gain or they will share. So it means that any type of the bonding, it depends on the valence electron, the outermost shell electron. These electrons determine the chemical properties of an element. So how an element behave, it depends on the valence electron. Elements of the same group column in the periodic table have similar chemical properties. This is because elements the same group have the same number of valence electron. They're saying that if you see in a group, top to bottom in a periodic table, in a group, you will find the elements which are in the same group, they have same chemical properties. And why they have the same chemical properties? Because they have the same number of electron in the last shell. So to understand this one, again, we'll go to the next page to understand it better, the periodic table. For example, with the example, I will explain to you. For example, here, this is the first group. If you see, this is group 1. Hydrogen, you have lithium, sodium, potassium, rubidium, cesium, francium. Then the second group, you have beryllium, magnesium, calcium, strontium, barium, radium. So these are all these groups. Now we'll say the first group. For example, see the first group. What is the first element? Hydrogen. Hydrogen has how many electrons? 1. If I want to draw the structure for hydrogen, I will draw like this. First shell, it has 1 electron. Mean the last shell and first shell same. It's 1 electron. The second one is lithium. If you see lithium, 3 and 7. It means that how many electron lithium has? 3, because it has 3 proton. If I draw the structure for lithium, it has 3. In the first shell, I will draw 2. In the last shell, I will draw 1. So see, hydrogen has 1 in the last shell. It is also has the 1 in the last shell. Now for more detail, go for sodium. If you see sodium, sodium is 11 and 23. So how many electrons, how many protons? 11. How many electrons? 11. So if I draw the structure for sodium, in first shell I will draw 2. In second shell I will draw 8. So how many left? 1. 1 will come in the last shell. See, hydrogen has last shell 1, lithium has last shell 1, sodium has last shell 1. So it means that the if any element in the group, same group, it has the same number of electron in the last shell. So group 1, all of them, they have 1 electron in the last shell. Group 2, all of them, they have 2 electrons in the last shell. Group 3, all of them has 3 electrons in the last shell. Group 4 has 4. Group 5 has 5. Group 6 has 6. And group 7 have 7. Group 8 is a noble gas. It is complete, that one. So this is how a periodic table works. Did you get this one? Please confirm. Okay. Now, so they're talking about here, they're saying that elements of the same group column periodic table have similar chemical properties. Why? This is because elements have the same group, in the same group have the same number of valence electrons. Isotopes also have the same chemical properties we discussed in the previous lesson. This is because isotopes have the same number of valence electrons. Elements in the last group of periodic table are called noble gases, the group number 8 we just discussed now. Noble gases have a complete outer shell with the 8 valence electron, except helium, which has 2. The full outer shell makes noble gases stable. Noble gases do not lose or gain or share electron. Other elements lose, gain, or share electron to achieve stability. So why an element or an atom lose or gain or share electron? Because it's want to complete the last shell. If the last shell is not complete, so the atom is not stable. So but the noble gases, they have last shell already complete naturally, so they have stable. So this is done by having the same electron configuration of noble gases with a complete outer shell. So how an element or atom can become, you can say, the stable, if it has a structure like noble gases. And what the structure of noble gases? Their last shell is always complete with the electron. So this is about the basic information about the ionic bonding. You can see the periodic table here, and after that we'll move to the next page, this one. Now we'll talk about what is an ion. When we're talking about an ion, so what is an ion? We talk about atoms. For example, see here that atom, yes, so this is lithium atom. This is lithium what? Atom, the first one. Why it is atom? Because number of proton and number of electron is same. In an atom, the number of electron and number of proton always same. Sorry, this is neutron, this is electron, down one. So number of proton and number of electron always same. This is. So whenever they talk about what is an atom, you can say in an atom, number of proton always equal to number of electron. Got it? Okay. Now, if you see the next one, for example, if lithium will take one electron more, before you have 1, 2, 3. Let's say one electron come from outside and come to the lithium. So now how many electrons become? 4. And how many protons? 3. Now they are equal? No. So which is more electron? So at that time, when their numbers are not equal, you cannot say it is an atom. It is not an atom. It is an ion. It is an ion. So if the electrons are more than proton, so it is known as an ion. If electrons are more than protons, so it is known as an ion. But if lithium will lose one electron before it has 3, it lose 1. So how many electrons are left? 2. So now how many protons? 3. How many electrons? 2. They are equal? No. But which one is more? Proton. So it is known as cation. And if the proton is more, you know proton has which charge? Plus. So how many charge? You can say plus 3. And what electron has? Negative. So negative 2. What the answer will come? Plus 1. So it will get the plus charge, positive charge. And here you have how many protons? Plus 3. And how many electron? 4. So what is the answer? Minus 1. You can see here. So this is how an ion is formed, and what is an ion and what is an cation. So this is the difference between an atom and an ion. Any confusion? Please confirm. Okay. Now, once again, if more detail, the difference between an atom and ion, as I told you, atom electrically neutral, no charge on atom, because if it is too positive, too negative, they cancel each other, charge is 0. Then same number of proton and electron, number of proton define its element. So how which element this is, it depends on number of proton. An ion electrically charged, different number of proton and electron may contain one or more atoms. So this is the difference between an ion and an atom. Now here the same thing they are talking about detail. What as an ion? Atoms are neutral because they have equal number of proton and electron. Ions are charged atoms. There are two type of the ion based on their charge. Number one cation, number one anion. So now see here ion. If it depend on charge, if it is positive, it's known as cation, and anion is negative. Positive means more protons. Negative means more electrons. How does it form? When atom will lose. Cation will form when by loss of electron, and anion by gain of electron. When an atom lose electron, it's become cation. When atom gain electron, it's become anion. So which type of elements make cations? Metals. If you see in periodic table, metal always lose electron. When the metal always lose electron, so they always form cations. Non-metal always gain electron, so they make anions. The ratio of electron proton. So in if you talk about number of electron proton, in cations more proton than electron, in anions more electron than proton. Which group from form this ion? Group 1 and group 3, because group 1 and group 3 all metals. So metal will form which ions? Cations. Then from group 5 to group 7 they form anions. That electronic configuration resembles the previous noble gases. So it is like a noble gas. When an element will lose electron and make cation, so it will become a noble gas. The like a noble gas, because last shall become complete. For example, if you see lithium, and try to understand this one, you have lithium, 3, 7. If I draw the structure of lithium, so in first shell I will draw 2, in second shell I will draw how much? 1 is left. So if it will lose, so last shell will finish. So only this shell is left. So this shell, how many it has? 2. And maximum how many can come? 2. So the first shell is complete. So it is also like a noble gas, like helium. So this is they are talking about. The size compared to original atom. Cations are smaller than original. Anions are larger than original. Why do these ions form? Because cations and anions both are formed because atom want to complete its last shell. So to achieve the stability by having the same electronic configuration like noble gases, so due to this reason, the ions form. Any confusion in this table, please confirm. Okay. Now they have given the periodic table. You can see this is the group 1, this is group 2, this is group 3, group 4. They're saying that from group 1 to group 3, because all these metal, so they always, what they will do? They will lose electrons. When they lose electron, which ion they form? Cations. And cations are what? Positive. So from group 1 to group 3. So in other say, you can say group 1, all element in group 1 always lose electron. How many electron they lose? 1. So if they lose 1, it's become positive 1. Group 2, all the elements in the group 2, when they want to lose, they will lose 2 electron. They cannot lose 1. They always lose 2. So when they will lose 2, so ion will become plus 2. And group 3 elements, always they will lose 3. So when they lose 3, it's become plus 3. So metal always lose electron. How many electron a metal will lose? It depends on its group number. Elements in the group number 3 always they lose 3 electron. Elements in group 1 always they lose 1 electron. So this is how they lose or gain. If you talk about group 5 always gain 3 electrons to complete the last shell. So its charge is -3. Group 6 always gain 2 electrons. So its charge is -2. You can see here. Group 7 always gain 1 electron. So its charge is -1. Group 8 do not lose or gain. So it is 0. So in the periodic table, from the group number, you can say its charge. If anybody will ask to you on group number 1, what is the charge? So you can say +1. Group 2, +2. Group 3, +3. Group 4, plus minus because it's share. Group 5, -3. Group 6, -2. Group 7, -1. Group 8, 0. No charge, like this. So this is how a periodic table is explained in terms of charges. Now we'll move to the next. Once again here, if you want to see this one. Now here you can see sodium. Sodium is neutral before. How many? Why it's neutral? Because sodium before has how many protons? 11. How many electrons? 11. Got it? So it is neutral, no charge on this one. But when the last shell, the last electron, here this electron, it will gain some energy, it will leave the sodium. When it will leave the sodium will, last shell is removed. You can see here how many shells? 1, 2, 3. But here how many shells? 1 and 2. So this is now how many electrons now you have? 10. How many protons? 11. So which is more? Okay, proton. So proton are positive, electron negative. What is the answer? +1. So this is become sodium ion. And what is the charge on this one? +1. All of them. Now this atom, now you will see the electron which is lost. The electron which is lost from sodium, it came to chlorine. See chlorine before. Chlorine, how many proton has chlorine? 17. How many electron it has? 17. So at this time, 0, no charge on this one. But when this electron will come, and now how many electron now become 18? How many proton? 17. So which is more? Electron. How much? 1. So -1. So chlorine will become negative ion. So now this is positive ion, this is negative ion. Positive, negative always attract each other. So they will make a bonding which is known as ionic bonding. Did you get this one? Any confusion? Please let me know. Confirm this one. Okay. Now again, they have given the example because in the exam, they will say to you, draw the diagram. Okay. Draw the diagram for the formation of ions. So you can write here. Here you will write only the last shell electron because sodium has first shell 2, second shell 8, then 1. So you will not write first 2, only you draw the last one. And chlorine has 17, first 2, then 8, then 7. So you will not draw first 2, you do only 7. So here sodium is 1 in the last shell, chlorine has 7 in the last shell. Got it? So when you will do this one, what next step? This sodium will lose this electron and sodium become positive ion. This chlorine will get this electron and become negative ion. So they will attract each other. In the same way, magnesium in group 2, it has 2 electron in the last shell. In which group magnesium? Group 2. And group 2, I told you, group 2 always has 2 electron in the last shell. So it will lose both and it will give to oxygen. Oxygen before has 6. Now when it will lose, oxygen have 8 now. 2, 4, 6, 8. So magnesium after losing 2 become plus 2. Oxygen after gaining 2 become minus 2. So cation, anion, again they attract each other and they make ionic bonding. The same thing I explained to you before, formation of cations. Metals atom are found on the left side of the periodic table. If you see the periodic table, so you will find left side, this side, all group 1, group 2, all and group 3, all metals. And here you have non-metals on the right side. Metal lose electron to become positively charged ion or cation. The number of lost electron is equal to the valence electron. How many electron a metal will lose? It depends on its group number. All the metals in group 1, they will lose how many electron? 1. All the metals in group 2, they will lose how many electron? 2. Group 3, how many lose? They will lose 3. Like this, if you want to know that and which metal or which element will lose how many electron, see its group number. Whatever the group number equal to the number of electron it will lose. A metal ion achieve the electronic configuration as the noble gases right before the metal. So they're saying that why the metal are losing electron, because they want to get the structure like noble gases. And what is the structure of noble gases? Last shell is complete. Example, when sodium lose one electron to form cation, in the same way chlorine gain, that one is known as the anion. So when sodium will lose, because how many electrons before have sodium? 11. Okay. So now if you lose one, it's become how many? 10. So first shell, how many? 2. Second, 8. So both shells are complete. You cannot put more than 8. So now sodium got the electronic configuration like noble gases, because noble gases always have the last shell complete. This is the formation of anions. I told you non-metal, they are right side of the periodic table. And if you see the periodic table, they will gain electron. Non-metals gain electron to form the anions. So this is how the anions are formed. Non-metal atoms are found on left side of the periodic table. Non-metals gain electron to become negatively charged ions, which are known as anion. The number of gained electrons is equal to the number of electrons needed to complete the last shell. For example, if you are talking about group 5, in group 5, all the electron they have, all the atoms they have how many electron in the last shell? They have 5. So how many they need to complete its last shell? They need 3 more. They need 3 more, because total can come 8. So group 5, all the elements in group 5, they need 3 electrons. So they will become charge negative 3. In group 6, all the atoms, how much they need? 2. In group 7, how much they need? 1. So like this, from the group number of non-metal, you can see that how many electrons are needed to complete their last shell. Again, why they will gaining electron? Because they want to have the electronic structure like noble gases last shell is complete. Because when you're talking about nitrogen, so before it has 5, it will take 3 more, so then it will become last shell 8. So this is like a noble gas. Any confusion? Please confirm.
No.
Okay, now they have given here the structure of a ionic bond. For example, here you have NaCl. So this is sodium and chlorine. So before sodium, it element, sorry, atom, chlorine also an atom. Why? Electron proton equal, electron proton equal. But when the sodium will lose last electron, so then it become positive. When chlorine will get the electrons, become negative. So positive and negative, they attract each other and they make the ionic bonding. And what is the ionic bonding? When two different ions, one positive, one negative, they gain each other, so they attract each other, so they make the ionic bonding. You can see here, this is sodium structure. So this one is orange one is a sodium and green one is a chlorine. So they arrange like this in regular pattern. Sodium, chlorine like this, and you can see here. So this is how a ionic bonding is formed, and ionic bonding, the structure is a regular pattern. You can see here. So here they're talking about the same thing here. The ionic bonds are formed when a metal atom lose one electron or more of its weight from its last shell electron to a non-metal. Both ions get full outer shell and achieve the electronic configuration of noble gases. The ions formed have opposite charges, positive, negative. They get attracted by strong forces. And what are the forces? Electrostatic forces. So these forces will hold them together. They don't allow them to go away from each other. So this type of bonding is known as ionic bonding. Now they use a term that the lattice or the giant ionic lattice. What does it mean? The loss and gain of electron in an ionic bond involves millions of ions, not only one atom and one, you can say sodium and one chlorine making this one. Millions of atoms are there. So when they arrange themselves in a three-dimensional crystal like this, you can see here. This is the same as like a three dimension, you can see. So when they arrange them in this way, this regular arrangement is known as lattice. If the question come in the exam, what is the lattice or what is the ionic lattice, what you'll say, a regular arrangement of alternating positive and negative ions. Because here positive, negative, positive, negative. This means that ions are always surrounded by other ions of opposite charges. Strong electrostatic forces of attraction hold oppositely charged ions in the lattice. So this is how a structure of an ionic bonding or ionic compounds. Now, if there is an ionic compound, how you will write? How you will write its formula? Very simple, very easy. Formula of ionic compound represents the simplest ratio of ions in the ionic lattice. The overall charge of the crystal lattice is neutral because the charges of the cation and anion cancel out each other. This is known as electrically neutral. Now, for example, here you have aluminium oxide. Aluminium oxide is formed due to ionic bonding. Why it is formed due to ionic bonding? Why? Because aluminium is a metal and oxygen is non-metal. So aluminium will lose electron and become positive, and oxygen will gain electron become negative. So this positive and negative, they attract each other. So if you see the periodic table, as I told you before, in the periodic table, try to understand. It's really, really easy. Now, they are talking about which two elements? They're talking about aluminium and oxygen. Aluminium is which group? Group 3, you can see here. Which group this is? Group 3. And I told you group 3, what charge it has? Plus 3. Then oxygen, in which group it is? 6. And 6 has what? Minus 2. You have to remember this one. Plus 1, plus 2, plus 3, plus minus 4. This is minus 3, minus 2, minus 1. Next one. So now aluminium has which charge? 3 plus or plus 3. Oxygen has which charge? 2 minus. This is their charges. So when they make a formula, this number is go under this one and this number go under this one. So formula of aluminium will be Al2 because this 2 come here and O3. It will 3 will come here. So this is the formula of aluminium oxide. Once again, let's say we will take one from here. We take sodium. Sodium has which charge? Plus 1 because group 1. Take from here oxygen. Oxygen has what? 2 minus. So this 1 will go under this one, 2 will go under this one. So formula will be Na2O. 1, but no need to write 1. Or you will write Na2O. So like this, you will make the formula. But if you have like this magnesium, magnesium in which group? 2. So if I will write here, magnesium what? 2 plus. And oxygen is what? 2 minus. So they are same, plus 2 and minus 2. So if numbers are like this, they cancel each other. So only formula will become MgO without any number. Got it? Same way, for example, you take sodium. Sodium is what? Plus 1. Take 1 from group 7, like chlorine. Chlorine is what? Minus 1. So plus 1, minus 1 cancel each other. So we will write directly NaCl. So this is how the formula is formed. Did you get this one? Please confirm. So here we were talking about the how the you can write the formula. And we gave the example of aluminium oxide. Now they have given another example, that is lead oxide. Lead is plus 4, plus minus 4, we discussed in group 4, and then oxygen is 2. So you can say this 2 will come here, 4 will go here. So you'll make a formula. What is that? Will be Pb2 and oxygen 4. So if this is 2, this is 4, you can simplify it. Divide by 2 both. So you will get PbO2. So this is simplification. This is simplify. So this is how you will write the ionic formula if you know that what is the charge on them, both elements, and then you can write their formula. So once again, they're talking about the formation of ionic bonds. We have already seen the formation of ionic bond when valency of an element is 1. Use the following steps to draw the formation of ionic bond for the element with different valencies. Step number 1. Use the periodic table to determine the charge of the elements involved. For example, if I will say to you, okay, I have two elements. One is potassium and other is oxygen. So they have a ionic bond because potassium is a metal and oxygen non-metal. So they have ionic bond. So what will be their formula? So I will see potassium. Potassium in which group? So when I saw the periodic table, it is in group 1. So it means it has a charge plus 1. Then I will see the oxygen in which group it is. So oxygen is in group 6 and group 6 has a charge 2 minus. So this is plus 1, this is minus. So this 2 will come here and it will come here. It will become K2O1, no need to write. So this is the formula of potassium oxide. In the same way, they have given here magnesium. Magnesium is group 2, it has plus 2. Fluoride is group 7, it has minus 1. So 2 will come here and 1 will come here. The formula will be MgF2. So this is how they will draw the formula. So see the step 1, use the periodic table to determine the charges of elements involved in the bond, which like we said, potassium is plus 1, oxygen minus 2. Step number 2, use the steps in previous section to write the formula. As I said, it will go here, it will go here. Using the formula, count how many atoms of each elements are involved. For example, if I got the formula, what is that? K2O. It means how many atoms of potassium we have here? 2. How many atoms of oxygen we have here? 1. So from the formula, you can tell the number of atoms. Draw a diagram to show the loss or gain of electron between atoms. For example, I want to draw the diagram for this one. So I told you that potassium is group 1. So how many electron it has? 1 in the last shell. And then oxygen is how many they have? 6 in the last shell because group 6. Got it? It means that if I will, this potassium will lose 1 electron and it will come here. So it will become what? How many it will become? Before they were 6, now it's become 7. Still it need 1 more. So then this potassium already lost. So then another potassium atom will come and it will lose 1 more. So both will come here. Now it's become 8. So this is become 2 minus, and 2 potassiums, they make this one. So here why they are saying this one, when you write a formula, it means that 2 potassium atoms are needed to make a bond with 1 oxygen atom. And you can see why, because 1 potassium can lose 1, but oxygen need 2. So another potassium will come and lose 2. So like this, they have to understand this one. You can see here number of electron lost by a metal atom equal to charge, and number of electron gained by non-metal is also charge of anion. So this is how it is formed. So please, if is it clear, please confirm this one. Here they have described, for example, magnesium is +2 and fluorine is -1. So when they make a formula MgF2, it means what? It means that this magnesium will lose 2 electrons. For example, here this is 2. But fluorine can take only 1. Then its shell is complete 8. So where the other will go? So then another fluorine will come and take that one. It means that whenever magnesium will make a ionic bonding with fluorine, so you need 1 magnesium and 2 fluorine atom, then they can gain electron properly. Okay, then there is another example. For example, here they give aluminium. Aluminium is 3. It means that whenever you have aluminium atom for ionic bonding, it will lose 3 electron because charge is 3. And then you have oxygen. It can gain only 2. So now question comes, what will happen? Because they are not equal. This is 3, this is 2. So what will happen? We'll see it now. For example, now see here, this is so aluminium. It lost 3. 1, 2, 3. And here is the oxygen. So oxygen, we took 1 oxygen, so 2 came here. 1 is left, this one. Then you took another oxygen and give 1 here. But oxygen need 1 more. Then you took another aluminium and you took 1 from here. Then 2 left. Then this 2 will come to another oxygen. So when you are writing the formula Al2O3, it means aluminium, how many atoms are involved in this bonding? 2, 1 and 2. And oxygen, how many involved? 3, 1, 2, 3. So from the formula, you will know that how many atoms of each element are involved in this bonding. So this is how you will do this ionic bonding. Now, the compound, for example, any compound which is formed due to ionic bonding. For example, we just said that aluminium plus oxygen. So they make a compound. What is that compound? Aluminium oxide. What is a compound? Aluminium oxide. So this compound, it is formed due to what? Ionic bonding. So this compound is known as ionic compound. So all the ionic compound, they have some properties. Number one, ionic compound have high melting and boiling point. Any compound which is formed due to ionic bonding, it has high melting point and high boiling point. They are soluble in water. If you take water and you put the ionic compound inside that one, so they are soluble. Ionic compounds conduct electricity only when they are molten. If you melt them or you will dissolve them in water, then they will conduct electricity. For example, if you have sodium, and it is solid. It means you have sodium on a paper in a glass. If you want to pass electricity through it, so you cannot pass electricity because it is solid. But if you put this sodium in water and make a solution, then you can pass electricity through it. Or you take the sodium and melt it, and then you can pass. So ionic compound only conduct electricity when they in a liquid state, mean molten, or when they dissolve in water. Ionic compound are hard but brittle. Brittle mean if you hit them, they will break down. This means that these compound can easily break like glass. You can break them easily. Now here they explain why, if it is a melting high melting point and boiling point, what is the reason? So you will see here. So in the exam, sometimes they can ask, okay, ionic compound have high melting and boiling point, and they will ask why. So ionic compound only melt when the strong electrostatic attraction forces are break. So to a large amount of heat energy is required to break these electrostatic forces. For example, you have sodium and you have chlorine when they make bonding. So you want to break the bonding, you have to give a lot of energy. Now, ionic compound conduct electricity. Why? Electric energy conductivity requires the movement of charged particles. Although the charged ions are available in solid state ionic compound, but they cannot move. If you have sodium and it is solid, there are ions, positive and negative ion, but when they are solid, they cannot move. When the ion cannot move, electricity cannot pass. So if you want to make them move, you have to melt them by heating, or you have to put them in water and make a solution. When dissolved or melted, ionic compound conduct electricity. Number three, being brittle. Why they brittle? Brittle means you will break it. If you hit them, they will break down like a glass into small pieces. Why it happen? The strong electrostatic forces of attraction make ionic compounds hard. However, when a force is applied, ions of the same charge come closer. This causes repulsion, and due to that repulsion, the ionic lattice break down. So this is the very important the table in which they told you the reason of each property. We said that ionic compound have high melting and boiling point. What is the reason? Here, ionic compound conduct electricity when they are molten or in a solution. What is the reason? This one. Brittle, and what's the reason? This one. Okay. So here they have given the explanation for the last one. For example, you can see here, this is the before breaking. When you hit them, so you will break this piece. So piece will break down. So this is showing it is a brittle. So this is the end of your unit 4 or the topic 4. Now we will see some past papers. Now, for example, the question number 1, they're saying that which change to an atom occurs when it form a positive ion. So when you will form a positive ion, when electron are lost, for example, you have sodium, it has one electron lost shell. When you lose it, it becomes sodium plus. So whenever you will get the positive ion, or you can get the cation, when it happens, when they lose electron, when they lose electron. So here the explanations are given there. If you have any problem, you can go through the explanation. Now see the question number 2. Now, electronic configuration of an ion, not atom, is 288. For example, 288. Actually, it was 286. But this atom got 2 electron from outside, so it become 8 now. So if it got 2 from outside, so what will be the charge on this one? It's become -2 because it gained 2. One electron has -1, and 2 electron when they come and join here, so this is become -2. Got it? So like this, you have the question in this all the worksheet. So I'm sending it to you. You can go through this one, and then inshallah next week we will go for the topic 5.